Oh yeah. Yeah. We back. Tekniikka High Tech. Hello guys. We back here in Tekniikka High Tech for one more session for our course of C programming language. Thank you for watching. Sorry for the delay. Yeah, we've been preparing high quality contents for you, so that's very important. You to subscribe our channel on Facebook, follow us on Instagram, Twitter, and also Facebook. Okay, share with your friends, please. Today is the lesson number 7 of this course. This lesson is going to be shared into 3 parts. This is the first part. We're going to have the second and the third as well. In this first part, I'm going to show you how the algorithms work, and also we can solve some basic exercises. And then on the second lesson, we're gonna be studying some more exercises, a little bit complex. And on the last one, on the third part, we're gonna have a very complex, not very complex, some complex exercise to solve, some quizzes and stuff like that, problems for you to problem solving to make your comprehension about the world, how the things work, how the programs work in your head. So far, we have so many artifacts that we can use in our favor to accomplish our goals. For today, we have a very short introduction. Then we're gonna talk about algorithms, sequencing structure. Sequencing structure is the main point of this lesson, because this is one of 3 more important things you should know about algorithms. And then we can solve some exercises. Talking about algorithms, what is an algorithm? An algorithm is something that you have to write before you write the program. An algorithm is some logical, ordered sequence of steps you have to follow to find a solution for a problem. The programming logic is used to build your algorithms, but the programming logic is nothing but the formal logic that you can use in your head, the best way to think, to find a way how things should be done. This is very important also for your everyday life. You have to think logically, in steps, in a sequence. You should know um, how you handle with mappers in the road on the road, how you solve problem, what you should do first. This is about algorithm. Okay, every engineering area in the science, um, they will need algorithms. They need programming, they need the C programming. This is what this is about, this lesson. Most programming languages use case sensitive. Okay, they differentiate between uppercase and lowercase, so be aware of that. When you declare a variable with lowercase, then you have to use the same way in the C programming language, C++, and other language, for example, most of the languages. There are some best practices that you have to. I said good practice, but best practice you have to follow to avoid errors. Nesting, you have to put indentation in your code. Put the code in different levels of indentation. Comment your codes whenever you can, please. Narrative description, flowchart, and pseudocode. These are the 3 different representation for algorithm. When we're talking about narrative description, we're talking about words, natural language. Natural, you can write an algorithm in natural language, like you solving some task in your kitchen. or even in your house, you have to write some steps or to think at least on steps. This is an algorithm in your head, okay, in natural language. Flowchart is a diagram, is some diagram that you can use to represent your algorithm. And pseudocode is some generic form of writing code that everybody can understand, everybody that knows this logic of algorithm can understand without thinking on any language of programming. Okay. Then we have the key structures for building algorithms. There are three key structures to build algorithms. Today we're going to be talking about one of them, which is the sequential structure. The sequential structure, sequencing, is all about thinking the logical way how to solve a problem. You put the steps one after each other, and the order matters. The first step will be will be executed first, the secondly, and so on. This is a sequence, okay? All algorithms should follow a logical sequence. So about condition we're gonna talk on the next lesson, not the next, because the next lesson will be a continuing of this one, the second part. We just solving some exercises. But after that, we will have in the future, maybe after the Christmas, we'll have some some lesson about conditions. This is very important because your algorithms, your program should decide which actions they should take. This is about decision condition. Repetitive structure is about loops. Loops are some artifacts that we use in the programming in programming for um, execute some block of instructions or even a single instruction um, as many times as we need. Okay, based on some condition or on some rule, for example. This is a flow chart. This is a flow chart. One of these structures that I told you. This is a flow chart. Begin. This symbol represents the beginning, and the same represents the end. And then you have the first task, second, third, and so on. Here you'll have your problem solving. And then this is pseudocode. Pseudocode is an algorithm like this written in your language, for example, in English, in Arabic, in Chinese, Japanese, French, and so on. And everybody can understand this algorithm, for example, is called example, and you have the begin, end, and then you have the comments. There is a language called Pascal. Pascal language, uh, the, the, the modern version of Pascal is called Object Pascal, is inside Delphi framework. When you coding in Delphi or Object Pascal, you coding something like this in English, very straightforward because you understand what begin is and so on. Okay, this is what a pseudocode is like. This is why Pascal is very good for academic purposes, but I prefer teaching the C programming language first. But before going to C, you should know how to write things like this, steps, okay, that everyone can understand. And then this is a sequential structure in C. You have the begin in C is this, the curly brace, open curly brace, and then you close the end with the close curly brace. And then here we'll have the comments. We're gonna see this after the next slide, right coding, okay? These are the exercises we want to code using this structure in C. So the very first algorithm is this: read the number and display its double. That's quite easy. Okay. Don't be bored. Okay, because this might be interesting afterwards. Oh, I'm receiving lots of blah 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 in the comments. Okay, no problem. So let's go. A number and display the double. Let's open our compiler. We have this standard input output library and math. We don't. We want the. I'm gonna delete this. You just need this library. You only need this when you want to use some mathematical functions like sine, cosine, logarithm, and so on, and some constants like p. You also find here. Okay, let's close it. So right now we need a number. Let's say that's an integer. A number. Let's call it number, and we want to calculate the double. It's double. Let's call it double. But we cannot call a variable like double because double is a data type. Be aware of that. Uh, double, doubled. Let's call doubled, double. That's fine. And then we can ask the user to enter the number. Let's do something like let me comment this out, and then write back, and you put here printf, and you say enter the number to calculate its double. And then the user is gonna enter the number using your algorithm, the sequence. First you printf, then you scanf the number, scanf, you'll scanf this number, okay? This is an integer. Since this is an integer, we need this or d. That could be an I or a D. That's the same. So here, as we saw before, you can see our previous lessons if you want. Then we have this the address of the variable in the memory. So the scanf can modify this when the user types it his number or her number or their number. Then after the number, we can calculate the doubled. Let's call it doubled, and we have the number multiplied by 2. How can we compute the double? Number plus number. This is the double, the double of the number, and which is the same number times 2. So we can have now the final printf. This is the final printf, and we have this double. Double is equal to this variable here, which is number plus the number itself. So we have this. This is the double. I have a problem here because I'm using double, the word double. This is enter the number to calculate its double. I have a problem here. I need to figure out where the problem is. That's good to find problems in our code. Okay, we have the printf here, the scanf, and then we have double is equal to number plus the number, and then we have double is equal to nothing. We have to put here the number. I can put here digit D, which stands for digit, or an I. That's the very same, I and D. So number 3 is the user is introducing 3, and the double is 6. That's all. That's normal. We could do this like this. As I said before, the logic, there are several logics to solve the same problem. No worries. The only thing you have to analyze is a sequential logical to solve your problem. So this is the very same. And for example, the number now is 5 and the double is 10. Okay, let's go to the second problem. Read two numbers, calculate and display their sum. For the sum, two numbers, I'm going to leave this for you. You can solve this by your own. Leave the solution in the comments. Let's go to this one. Okay, this one. We're going to read a temperature in Fahrenheit, and then we convert it to Celsius degree. Okay, the temperature should be a float because they are real numbers, not integers. So let's call that Fahrenheit. I have to copy this word. This is difficult to me. I don't know whether this is German or something like that. I can put here Fahrenheit. This is the temperature in Fahrenheit. Then we will have the temperature in Celsius, like this, Celsius, Celsius degree, and we can have enter the temperature in Fahrenheit, enter the temperature in Fahrenheit, okay? Then after the user introduced the temperature in Fahrenheit, no, after he sees this message, he's gonna enter the temperature here in the scanf function, and then we can calculate here the temperature. The temperature is another variable. We can put here the variable temperature, and then we'll display the temperature here. But here, we're going to use a formula to calculate, to convert the temperature from Fahrenheit to Celsius. Oh, this is Celsius. Okay. I don't need this variable temperature anymore because I'm using Celsius. So here we use the formula, this formula, 5 divided by 9. Then we have this times this Fahrenheit minus 32. So Fahrenheit minus 32. Let's put it into brackets. So inside parentheses, that's fine. And then we can see the solution working. Here we have a problem because we have a digit here. That's bad. This is not the double. This is the temperature. Let's call this temperature, or let's call this um, degrees Celsius. Okay. Oh man, that's frozen. No worries. This is degrees Celsius. And this is a float, not a digit. And this is also a float, not a digit. Okay. Now we're gonna go and we put, let's suppose we have a temperature which is 50 in Fahrenheit. Oh, our program is saying this is 0. That's bad. The 0. I know why this is happening. I did it for you to see. The result of this division is 0 because this is an integer division. So we have to convert one of the numbers to float, something like this. Okay, or both. We could also put here dot 0. So let's try it again. Now the calculation is fine. Okay, you have 50 in Fahrenheit, 50 minus 32. You have the result. This result, which is something like 18, something like this. 18 multiplied by, I think it is 18. Yes, 18 multiplied by 5. You have maybe 90. And then you divide by 9 and you have d0, okay? That's fine. So let's move to the other exercise, which is for given the base and the height of a triangle, display its area. Yeah, we can do, you can calculate the area of a triangle and then the area of a circle. I know you can compute this. We can do this both together, calculating this, the area of a triangle, and then calculating the area of a circle. So let's go. For the area of a triangle, the formula will be this one, okay? And here you have the base of the triangle, and then you have the height of the triangle, And here you say to the user, enter the base followed by a height of a triangle, So the user is going to introduce a float here and another float here. And these floats are the base here, followed by the height. Base followed by the height. And then you just need to calculate the area. So let's say area And this is not anymore the temperature. This is the area we're calculating. Triangle area. And the triangle area is going to be calculated using that formula, which is the base of the triangle multiplied or times height divided by 2. This is the area of a triangle. So I think that's fine now. We can go ahead. Height is badly written somewhere here. Height. Have I wrote height like this? Where did I write this? I'm not seeing the. Oh, this. That's bad. Okay. The base of the triangle. Let's say the base in centimeter or meters is something like 10. Base. The height is 30, for example. We have this area, but this is too bad. This is bad to me because I have a multiplication division and I have a minus here. I don't know where this minus is coming from, so we have to solve this problem. We have a problem here. Let's go ahead. So what's the problem? We have the base, then we have the height, then we have the area. So we multiply the base by the height and divide it by this, and we have minus blah blah blah. No, that's not good. Yeah, we have to find where the problem is. We have to debug this. Debugging is finding the problem, the bug or the error of a program. This is what we're gonna do. Let's see. So we have these, the variable declarations, then we have this text, and we have scanf to scanf base height, and we have what do we have here? I can close this. We have an area is equal to base times height. Yeah, I would like to see where the problem is coming from. I couldn't see so quickly. Well, let me try it again. 5. Oh, yeah, I wrote that badly. I know what's going on. I forgot to type the other number. Let me try it. Oh, this is the comma, man. We shouldn't put a comma. If you don't want to put the two numbers inside the same scanf, you can split them something like this. You can split this by doing this, by putting a single number here on this scanf and then the other number on the other scanf, like this. Yeah, this is safe. But you can also do this. But don't put a comma here in the middle because scanf is reading from a file or from a string. This is reading from this. When it finds a space, it reads the other number, a space or an enter, for example. The delimiter can be something like 10 space 50. 50 is the height of the triangle. No, this is too much. Let's put 40. With 40, we have this area. 200 is the area. If these units were given in centimeters, this is centimeter. If this was in millimeters, this is millimeter as well. Let's go to the other. Oh, this is the area of a circle. Let's say a circle is identified by its radius. Okay, radius. This is the radius. Enter the radius of a circle. Enter the radius of a circle. The radius of a circle is entered by the user here, the radius, just the radius, without any other information. And with the radius, we can calculate the area something like this. You have you have radius radius um radius radius times radius. This is something like the power of radius by 2. This is the power of radius by 2, okay? And you have also here the constant p. The constant p, is this a multiplication? Yeah, this is a multiplication, okay? You have here the formula. p multiplied by this radius powered by 2. So the p, as you know, p is a const, p something like 2.1415, and this is p. This is the circle area is calculated like this. Um, am I right? This is p. Um, uh, I have a bug in my head. I'm thinking whether this is really p or not. But I can confirm if this is the real p because I have a way to print p. If you want to print p, you have to include here a library, the library math.h, and inside that library you have a const called mp or pi, mpi. So let's try this. Yeah, I have a problem here. It's saying warning, type defaults to int of p. Um, oh, what is that? I have this const. Okay, I need an int here. Not, I need a float because this is a floating point number. And I have another problem here. It's saying undeclared first use. Which one is undeclared? This is radius is undeclared, not the radius, but the area variable. We need to declare here the variable before using it. Okay. So I don't care which number is this. I just want to know. Yeah, I had a bug in my head. I know I was wrong. This is free. I never I never I never was mistake about the p value in the past. Yeah, that's crazy. Okay, you can use like this, and now you can print out the area of p or pi. I don't know how to say that. Let's say the radius is 10. Have this area. This is the area of the circle. Remember this. And now instead of using this p from my head, let's use mp, the constant coming from math. Let's say let's put the 10 as well here. 10 is the radius. Okay, that's fine. This is the radius of the circle. If you wanted to print the diameter of the circle as well, you could put something like semicolon here, and you put the diameter is equal to another float, and here you can put diameter. The diameter the diameter is should also be calculated here. The diameter is nothing but 2 multiplied by radius, or radius plus radius. This is the diameter. So let's try it out. I have a problem. The diameter is not declared here. All the variables you use in C could be declared by specifying its type. Okay, so that's fine now, I suppose. I have this, and the diameter is just the double of the number. Okay. Last exercise, I suppose, given two sides of a rectangle, calculate the area. This is very easy, and we can do this to calculate the average of 2 marks from a student. So in this case, let me delete these, all of these. I don't care. All of these. We can do something like we have something like this is the mark 1. Um, this is the second. This is I'm gonna call this result. The student has the result 1. This is the weight. Am I writing well weight? This is the weight 1. The weight of this mark in the final average, okay? And yeah, that was fine mark. This will be the mark 2, and this is the second weight related to this second. So now you can say the user printf type or enter the first enter the first mark followed by its weight. This will be the weight followed by its weight, and yeah, that's fine. And then you're gonna ask the user to enter the second mark followed by its weight as well. And here you can put the scanf to scan, okay, for the program to scan the first mark and its weight. So mark, no. First of all, you have to put the type, which is float, space, another float, and then you have the mark. You have to put here the direction of the address of this variable mark 1, and then mark 2. Oh, the weight, okay, weight 1. Okay, that's fine. The user is gonna enter here, and here is gonna enter the second mark and the second weight. Okay, that's fine. And at the end, you just need to calculate the average. The average is gonna be calculated here. Average is equal to mark 1. If you had some very simple calculation, some arithmetic average, you could calculate the mark 1 plus mark 2 divided by 2. This is the normal behavior, the normal average would be like this. And then scanf, printf, average equal to the variable average, which is a float average. Okay, that will be something like this. We don't want this. We want another kind of average. This weighted average. Okay, a weighted average is something like this. You have the first mark multiplied by its weight, weight 1, and here you have the second times weight 2. Okay, but let's say the weight is given in numbers like from 1 to 100, like this. In this case, you have to convert these numbers into percentages. The way to convert this is dividing the weight by 100. Okay, when you divide the weight by 100, you're converting any number from 1 to 100 to the percentage. And here you can also have this divided by 100. So that's fine. Let me see if everything is going fine. No, I'm missing some part. Okay, that's fine. That's fine. But I need some more. Okay, let me delete this. I don't care. No, I care. I have to put here some more. And also here. Because this first is closing here. This second is closing this expression. This is closing this whole expression. And this is only closing this division. But we don't even need these parentheses, because for the division and multiplication We have same priority. We don't care, but I'm just writing like this for your better understanding. I need here some semicolon instead of colon. Yeah, that's bad. Let me see where the error is. I need here the address operator is necessary here and also here. Okay. So the first mark is 11, for example, no 11, 15, 14, and its weight is 30. Let's say like something like that, 30%. 30, which is going to be converted into 30% here. And then the second is, let's say 9, and the average is 70. 7% is 70%. So in this case, the mark, the final average is 10 and half. Although the student had 14 in the first mark, the problem is the second mark, which is negative, which is very low at 9, has a very high, a higher, a higher weight um, in comparison with the others. So we can stay here today. Thank you very much for those who watch our videos. In the next lesson, we will be continuing with some more interesting exercises. Don't forget to subscribe our channel in YouTube. Follow us on Facebook, Twitter, and Instagram. Share with your friends, and thanks a lot. Leave in the comment your better solutions. See you guys.